Imagine a planet with an atmosphere unlike anything we've ever seen before, not oxygen-rich like Earth, not hydrogen-dominated like Jupiter, but instead filled with carbon compounds. Thanks to the James Webb Space Telescope, we've just discovered a planet with a never-before-seen carbon atmosphere. This could change how we think about planets, their chemistry, and even the possibility of life elsewhere in the universe. Let's dive in. The James Webb Space Telescope, or JWST, has been operational since mid-2022, and it has already revolutionized our understanding of the cosmos. Unlike previous telescopes, JWST can peer into the atmospheres of distant exoplanets with incredible precision. It does this using a method called transmission spectroscopy. Here's how it works. When a planet passes in front of its star, some of the starlight filters through the planet's atmosphere. Different molecules absorb different colors or wavelengths of light. By studying these tiny fingerprints, JWST can figure out what the planet's atmosphere is made of. And now, one of its latest discoveries has stunned astronomers: a planet with an atmosphere dominated by carbon-based molecules. The planet in question is a gas giant orbiting relatively close to its star. Normally, exoplanets of this type have atmospheres rich in hydrogen and helium, with traces of water vapor, methane, or ammonia. But JWST detected something unusual, an atmosphere with a very strong presence of carbon compounds. We're talking about carbon monoxide, carbon dioxide, methane, and possibly even more exotic carbon molecules. This is the first time astronomers have ever observed a planetary atmosphere where carbon seems to dominate the chemistry in this way. It's like finding a planet with an alien recipe, something totally outside the cookbook we've been using to understand exoplanets. So why is this discovery so groundbreaking? There are three main reasons. 1. Planet formation theories. Carbon-heavy atmospheres suggest that this planet might have formed in a different part of its star system, possibly beyond the carbon line, a region where carbon-rich ices were more abundant than water. This challenges current models of planetary formation. 2. Chemistry of alien worlds. Until now, most planets we've studied had atmospheres dominated by hydrogen, helium, and water vapor. A carbon-rich atmosphere means entirely different chemistry is happening on this planet. Imagine clouds of soot, diamond rain, or methane storms, phenomena we've never even considered before. 3. Implications for life. Now, this doesn't mean the planet is habitable. It's likely a hot gas giant with no solid surface. But the fact that carbon chemistry can dominate an atmosphere is important because carbon is the backbone of life. On other, smaller planets, such chemistry might create environments where life could potentially emerge. Scientists have long theorized about the possibility of carbon planets, worlds made not of rock and water, but of carbon and its compounds. Such planets might have surfaces of graphite, mountains of diamond, and skies filled with hydrocarbons. This discovery might be the first step toward confirming that such exotic planets truly exist. What's even more fascinating is the possibility that some of these carbon-rich planets might orbit in their star's habitable zone. If so, their chemistry could be radically different from Earth's, maybe not water-based life, but something we can't even imagine yet. JWST used its near-infrared spectrograph, NIRSpec, and mid-infrared instrument, MIRI, to detect the carbon signatures. These instruments split light into its component colors, revealing the distinct absorption lines of carbon dioxide, methane, and carbon monoxide. The precision is so high that astronomers can not only tell what molecules are present, but also estimate the temperature and pressure of the atmosphere. In this case, the readings confirm a hot, dense, carbon-rich environment. To put this in perspective, Jupiter-Saturn, mostly hydrogen and helium with a bit of methane and ammonia. Neptune-Uranus, also hydrogen-rich, with methane giving them their blue color. Earth, a nitrogen-oxygen atmosphere with trace carbon dioxide, but this new exoplanet, its chemistry looks nothing like any of these. It's a true outlier, showing us that the universe is far more diverse than we imagined. It's like walking into a forest expecting pine and oak trees, and instead finding an entire ecosystem of plants you've never seen before. This is just the beginning. With JWST's ongoing mission, astronomers will target more exoplanets to see if carbon-rich atmospheres are rare or more common than we think. If we find many such planets, it could mean that carbon worlds are a whole new class of planets in the universe. In the future, missions like the Nancy Grace Roman Space Telescope or even potential interstellar probes could study these planets in greater detail. For now, JWST has given us a tantalizing clue. The universe has surprises we haven't even dreamed of. So what does this all mean? We've taken another step toward understanding the incredible diversity of worlds out there. From lava planets to ocean worlds, from frozen giants to carbon-rich atmospheres, the universe is showing us it's far stranger and far more fascinating than science fiction ever imagined. And who knows? Maybe one day, a planet with an atmosphere like this could even hold the key to discovering life beyond Earth. This is why JWST is often called a time machine and a discovery machine. With every new observation, it's rewriting the textbooks of astronomy. If you enjoyed this deep dive into JWST's latest discovery, don't forget to hit like, share this with your fellow space lovers, and subscribe for more amazing updates from the universe. What do you think about a planet with a carbon-rich atmosphere? Could exotic life exist there? Drop your thoughts in the comments. I'd love to hear your theories. Thanks for watching, and as always, stay curious.